Okay, today we're going to talk about the intro to quadratics. You should have the notes with you that I gave you on Friday. If you do not, then you can get them out of the Friday folder real quick. That's on the bulletin board. Okay. All right. Basically, it's kind of a review. We've already talked about the intro to quadratics, but now we're going to go ahead and expand on what we already know. A linear function is represented by the equation, and this is just a review right here, but a linear function is represented by the equation y equals mx plus b, and its graph is a line. Thus, the word linear, okay, meaning line. So it looks like this or this, just depending on the slope, and so on and so forth. Okay, a quadratic function is another type of function that is represented by the equation y equals ax squared plus bx plus c. Now, in Algebra 1, you're going to talk primarily about y equals ax squared plus c. We're going to generally leave out bx a little bit, but it's good to know, okay? So, it's represented by the equation y equals ax squared plus bx plus c, and its graph is U-shaped. And again, this should be reviewed, you should know this, and is called a parabola. Okay? So, it looks like this, or an upside down U. Okay? Not a sideways U. That would not be a function. It's not a function because it does not pass the vertical line test. Okay? Alright, for our quadratic, A is the quadratic factor. And we know this because it has the x squared attached to it, okay? That square value is what's going to give us that parabola, and we'll talk more about that in detail later. But this is going to be huge as you progress through geometry into Algebra 2. Algebra 2 is where it really comes back and gets you again. But A is a quadratic factor. It determines how wide or narrow the parabola is. It also determines whether it opens up. I'm going to put this on the side. It opens up. If it's positive, that means you actually have a U-shaped graph. Or it opens down if it's negative. So up looks like this, down looks like that. And then C is the constant. And that's our naked number. Okay? You can always tell the constant in both y equals mx plus b and y equals ax squared plus bx plus c because it's the naked number. Remember, the naked number is the number that does not have a variable attached to it. It's just a number that stands alone. Okay? All right, make sure you have that down. And then we're going to go ahead and move on to our next slide. Okay. The parent quadratic function is y equals x squared. Or in function notation, it would be f of x equals x squared. Okay? If you remember, what's the linear parent function? Yeah, it's y equals x. Okay? Now, in the parent quadratic function of y equals x squared, it's where a is equal to 1 and c is equal to 0. So we're going to graph it by filling in the table, and then we're going to plot the points. So if we have negative 2, we're going to have y equals negative 2 squared. Negative 2 squared is 4. And when you do this, you need to make sure you put your if you do this in your calculator, you need to make sure you put the negative 2 in parentheses and then square it. Otherwise, it'll give you the wrong answer. Okay? We have y equals negative 1 squared, and that is 1. And the reason it's positive is because a negative times a negative, because a square, negative 2 times negative 2 is positive 4. Y equals 0 squared, obviously 0. Y equals 1 squared is 1. Y equals 2 squared is 4. Notice that repetition, that pattern repeating itself. And again, we'll talk more about that on a later date. Let's go ahead and graph this and see what it looks like. First of all, we should know it's going to be at the origin. We should know it's going to be a parabola. So our first point we said was at negative 2 on the x. And 4 up. So negative 2 over and 1, 2, 3, 4 up. So, get a different pen. Somewhere in there. Our next point was negative 1 over and 1 up. Next point was 0, 0. Our next point was 1 over, 1 up. And our last point was 2 over, 4 up. So there's our dots. Let's go ahead and create our parabola. And it looks something like that. Okay. So now that we've graphed it, let's go ahead and analyze the graph. Parabolas are symmetrical. What that means is that if I draw a line down the middle of my parabola, okay, which is actually called the axis of symmetry, something like this. In this case, it's the y-axis. But if I draw a line right here, it's going to be the same on both sides, okay? And this line right here, like I stated a second ago, is called your axis of symmetry. And that's going to be important for you as we move forward and all the way into Algebra 2. Okay? This point right here, okay, and that's this point right here, is called the vertex. Basically, your vertex is where your parabola comes to a point, okay? If it's on the bottom, and you might write this down. I'm not going to write this down because we're going to talk more about this later. But if it's on the bottom, it's called the minimum. If it's on the top and the graph is upside down, and it's an upside down U, then it's called a maximum, okay? And again, we'll talk about this more in just a minute, okay? Parabolas are symmetrical, so there is an axis of symmetry. That's what goes here, and I've already showed you that. And that axis, again, is just a line that you can draw down the middle through your vertex that creates even sides, even halves of your parabola. Okay, and it's not always the y-axis. Sometimes it's just a line like y or x equals 2 or something like that. Okay. The axis of symmetry is a vertical line. It's always a vertical line. And has the equation of x equals some number. Okay? So an example would be, in this case, x equals 0. So you go to the 0 on the x-axis and draw a vertical line through it. Okay? The point where the graph changes direction is called the vertex. In the graph, and we've already talked about the vertex, okay, that's just a point, okay? In the graph of the parent function, the vertex is the same as the y-intercept. Okay, this isn't always going to be the case. This just so happened in the parent function of y equals x squared. In this graph, this point is called a minimum. And again, we know this because does the graph go any lower than 0? No. So the minimum it can go is 0. Okay? If I flip it over and I have a graph like this, you would ask yourself, does the graph go any higher than whatever that vertex point is? And your answer would be no. So that would be a maximum. Okay? So that's a max. All right, let's move on. The point where the parabola crosses x-axis they're also called x-intercepts. Excuse me. The point where the parabola crosses the x-axis are called the x-intercepts. That's just like where a normal linear equation, when a linear equation crosses the x-axis, it's also called an x-intercept. But they are also called, in this case, and we've talked about this before, you should be able to answer this on your own, they are also called zeros, solutions, and roots. Remember, x-intercept, zero, solution, roots all mean the same thing. All right, so let's look at this first example. The graph of the quadratic function y equals x squared minus 2x minus 8 is shown below. What are the coordinates of the vertex? So I need to find the vertex. Where's the vertex? Right here, right? Okay. And if we go down, it looks like our graph is going by 2's. So if we go down, the little in-between marks are 1. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. It looks like it's 9, comma. How many over is it? Looks like it's just 1 over. So 9 over, excuse me, I went the wrong direction. So it's 1 over 9 down. So your coordinates will be 1, comma, negative 9. Is the vertex a maximum or a minimum? So you have to ask yourself a question. Does it have a limit on how high the graph can go? Look at the arrows. Which direction are they going? Does it have a limit on how high it can go? No. If your answer is no, then you do not have a maximum. Okay? Does it have a limit on how low the graph can go? Well, yeah. You got to stop it right there. So you do have a minimum. Okay? What is the equation of the axis of symmetry? This is where I lose a lot of students because they forget how to write this. But this is very, very simple. Okay? All I have to do is I would essentially draw a line through the axis of symmetry. Okay? Well, I go through the vertex. and I draw a line. Okay? Now, the axis of symmetry is always x equals the x value of your vertex. So in this case, my x value is that 1 right there. So my equation is always x equals 1. If my vertex was 2 comma negative 9, my equation would be x equals x equals 2. Okay? And think about it this way. All my x values along this line here are 1. There's no other x values. Okay? And what are the solutions of the quadratics? Again, solutions means the x-intercept. So what does it cross my x-axis? Well, you can easily see that right here. So I would have x equals 4. And right here, at x equals negative 2. So I have two solutions. That's going to be a trend because this exponent right there tells you how many solutions you should have in a problem. Okay? So because we're doing a quadratic and it's an x squared, we have two solutions. All right, let's go to our next example. Okay? In this example, it says the path of the ball is kicked upwards can be described by h equals 35t minus 5t squared. Got to be careful here. These are out of order. But that's okay. We'll work on that. Where h is the height of the ball in meters and t is the time in seconds. How high is the ball after 3 seconds? Okay, well, all you got to do is go to 3. Looks like we're going by ones. 1, 2, 3. Okay. So we go to 3 seconds. All we have to do is draw a line from 3 seconds. And then once we hit the graph, we're going to draw a line to the y-axis. And we can see that it's 60 meters high. Okay. After how many seconds will the ball be 50 meters high? Okay, so now we have to do it the opposite direction. First we went to 3 seconds. Now we're going to go to the height of 50 meters. So 50 meters is right here. And we just go until we hit the graph. We hit the graph. Once we hit the graph, we go down to the x-axis. And we see it's about 2 seconds. Is that our only answer? Because look here, what if I keep extending my graph out? On my line from 50 meters. I hit the graph a second time. And so then if I go down here, it's not only after 2 seconds, it's also at 5 seconds. Doesn't that make sense? Think about it. When you throw the ball up, you're going to throw the ball up to a height. It's going to hit its maximum height, and then it's going to come back down. And as it goes back down, it's going to hit all the heights it went past as it went up too, right? Doesn't that make sense? Okay, for it to have 2 times at which it's at a certain height. When does the ball hit the ground? Okay, well, it looks like this is 0 right here. And so the ball starts at 0. It starts on the ground. But he asks, when does it hit the ground? So then what's going to happen is you're going to throw it up. And it's going to end up back here at 0 again. Except this time, it's 7 seconds at this time. Okay? So you could say at about 7 seconds. Or at 7 seconds. I wouldn't say about because you know clearly it's 7 seconds. And then finally, when will the ball reach its maximum height? Maximum height, okay? I'm going to erase the stuff we've done on the graph so I can see a little bit better. We don't need that anymore. Okay. So, we know it has a maximum because it tells us in the question, but we should also be able to identify that it has a maximum here as well because it vertex, you can't go any higher than that, right? Okay, so when does it reach its maximum? Looks like it reaches its maximum at about 3.5 seconds. And remember, it says when, not where, so you need to make sure you read the question. When will the ball reach its maximum height? It looks like about 3.5 seconds. Okay, if you wanted to determine where it hit the maximum height, okay, you could say it's just barely over 60 meters, but it's not asking for that, right? All right, that's your introduction to quadratics. Again, make sure you're taking good notes. Make sure you have this down, and then you are all set for doing your assignment. So do your assignment and be prepared for the next activity tomorrow. Have a great day.